By combining quantum physics and AI, I create a spatial-temporal neural net. The special theory of relativity is a useful explanation for the space-time continuum because it maintains the order of past, present and future. For example, the spatial-temporal length of the world line referring to a laser which travels in space and a watch equals 0. This is the result of the time dilation, because time freezes if one object travels with the velocity of light. From the perspective of a moving observer and an observer at rest, the impulse of an object moving towards a wall is equal. The impulse is equal for both observers, although the object moves more slowly from the perspective of the space traveler than from the perspective of an observer at rest. From the perspective of the space traveler, every event occurring in the resting system is slower. This is because the mass of the object moving towards the wall is larger from the perspective of the space traveler than from the perspective of the observer at rest. Therefore, the mass of an object depends on its motion. Mass and energy are equivalent. The photonic computer chip consists of a grid which distributes optical signals. This grid allows the complex routing of the signals. The chip consists of 2 layers of photonic light conductors. It's possible to use the chip for image processing and pattern recognition tasks. If you want to change the state of a neuron, you use different signals. If I want to change the state of a neuron in an optical way, I change the intensity of the light signal. One way to train the photonic neural network consists in running a training protocol on optical circuits. This is called on-chip training. Laser beams are fired into the circuits and beam splitters change the signals. Scientists compare the output of the circuit to the expected output. My quantum reinforcement learning algorithm for a high-level programming language combines the quantum master equation for the reinforcement learning procedure with a quantum net. I calculate the probability of the transition of eigenstates of the Hamiltonian operator in the Hilbert space. These eigenstates of the Hamiltonian operator correspond to energy states. The spacetime net solves the quantum master equation for the reinforcement learning procedure. Quantum entropy designates the measure of probability detected in a quantum many-particle system.